In comparing different building standards, we identified some key metrics that we wanted to use in this comparison. Starting from thermal comfort, we're going to see how that is assessed and how different building standards compare. We looked at indoor air quality in terms of air supply, filtration, air tightness, and control of indoor pollutants. We looked at resilience and durability, which defining metrics for resilience was kind of interesting, but we did that. Then looked at operational energy efficiency. That is probably one of the most straightforward metrics that we used. And we looked at embodied carbon. We have a dozen or so different building standards from the 2018 IECC all the way down to PHI passive house. And this is a table showing the thermal comfort, indoor air quality, resilience, durability, operational energy efficiency, and embodied carbon. And as you will see at the end of this series of videos, the summary table will look something like this, so very complex, because these are very different metrics, and it's hard to compare 50% reduction of energy use intensity with better air filtration and higher thermal comfort. So because of you cannot really compare apples to apples effectively there, we made up a scoring system out of, we're trying to simplify the comparison. It's a point system made up. We try to have a simpler comparison between different standards over metrics that are significantly different from each other. And we assigned 20 points to each. Let me skip forward a little bit so you can see what I'm talking about. These are the different scoring that we have. So one score was thermal comfort, the second score was indoor air quality, third was resilience and durability, fourth was operational energy reduction, and last was embodied carbon reduction. For each of these, we assigned 20 points, so 100 points total. And then for each value metric, we identify criteria that would build that value. For example, for thermal comfort, we identify the comfort criterion as set by PHI and FUSE. But also the reduction of air leakage is important for thermal comfort. So of those 20 points available, we divided them equally across the criteria we identify for each metric. The equal breakdown of those points, we decided to have a flat, even division. So if you look at the indoor air quality, we found 5 criteria. And so those 20 points are divided equally. So each criteria gets 4 points. That is because at some point, one's personal opinion matters a lot in how points are allocated. So we wanted to keep this pretty neutral because my opinion is going to be different than yours. Lastly, different criteria will provide value for different aspects of the building. For example, the air leakage reduction does make your building more comfortable. So we assign some points in the thermal comfort. Will also improve your indoor air quality because you keep the pollutants out by air seen in your building. So you have some points in the indoor air quality. It also makes your building more durable. So the air leakage reduction also provides you from some points in the resilience and durability score, as well as it reduces your operational energy. So you will find that also there. But it's actually baked into the EUI reduction. So this is the scoring that we provided. And again, this is the intention here was to simplify the comparison between different standards. Take it or leave it. It was a way to make it more digestible to people that are not deep into the metrics and different numbers.